Good morning, Year 7. This is Mr. Cooper. We're going to slightly change the way that we do things after half term in the work we set for you. It's been great setting you problem-solving tasks, and so many of you have really enjoyed those and have sort of really struggled your way through some of the trickier problems, which is great. But we've decided to move back to the scheme of work, and for this half term try and push on and expose you to a bit of new content, although actually the topic we're doing is entitled Handling Data, and much of it you will have met before. So in many ways it's more revision. Now you may wonder why I'm doing this and not your normal teacher. It's not that your normal teacher isn't interested in you, far from it, but we've shared out the setting of work, and because I'm head of department, I got to choose the best groups, so that's why I've chosen you. I love solving problems. I did an engineering degree at university, so we're still going to be doing lots and lots of problem solving, and particularly I think we'll sort of stick with new content on Mondays, and then Fridays we'll do some problem solving, maybe based around that. That will certainly be the case this week. So here we go. We're going to talk today about comparing two sets of data. I hope you're okay watching this video, and there's also an attachment with some questions and some answers. Listen to the end of the video because I don't need you to do all of the questions. So I want to tell you about two of my favourite students, John Doofus and Bill Geeksworthy. So John and Bill are really good at maths, and I really enjoy teaching them, but they're also quite good at athletics. And here are their times for the last few 100-metre races that they have run. These are in seconds. I don't know if you've ever timed yourself over 100 metres, but yeah, these are not the fastest times, but they enjoy running, so there we go. And what we're going to do is we're going to compare them. And we're going to compare them in two ways. We're going to firstly look at the average time for each of the two students. Now, you've met averages before. An average is a typical value in a set of data. And an average tries to take a set of data, like John's numbers here, and represents it with a single value. And that's tricky. That's tricky to represent one whole set of data with just one number. And that's why we've got three ways of doing it. We have three ways of working out the average, and these should be words that you are familiar with. I'm going to remind you about them, and there's a reminder about the definition on the sheet I've attached. So the mean is probably what most people think of when we talk of averages. This is where you take the data, you add it all up, press equals on your calculator to get the total, and divide by how many values there are. So that's the mean. The median is where you take the data and you put it in order, and you find the middle value. And the mode is the most popular value, the number that occurs most often. So I'm going to pause the video at that point. I'm going to get you to pause it as well. And I'd like you to have a go at working out the mean, the median and the mode for John Doofus and Bill Geeksworthy. And if you can't remember, if you haven't, if my explanation wasn't clear, then have a look at the explanations at the top of the sheet I've attached. I'm going to pause the video and come back when you've had a go at that. Okay, so I added up John's times and got 173 seconds. There were 8 times, so I divided by 8, got that rather nasty number. So I didn't say, but I chose to round it to 1 decimal place, 1 dp, 1 decimal place. And I did the same for Bill. I added up Bill's scores. Bill only had 7. Times. Bill only had 7 times, and that came out with an even more horrible decimal number, so I rounded that to 1 decimal place as well. For the median, look, I've put John's times in order, and I've put Bill's times in order. I'm going to start with Bill. Some of you will realise why. So if I'm looking for the middle, have you ever used this trick where you cross out and then you're left with a number in the middle? So that's 21. The median for Bill is 21. Sorry, I'd crossed out up here because when I put them in order, as I write them down, I cross them out here so I know I haven't forgotten any. That's a good trick. I did the same here. So as I wrote them down, I crossed them out up here so I knew I wasn't going to forget any. Right, so here we go, crossing out trick. 2 in the middle. I don't know if you have come across that before, but if you have 2 values in the middle, you just work out what's halfway between them. And this is easy because halfway between 20 and 20, well, is 20. The mode, that's the most popular, so that's nice and easy for Bill. 21 seconds is the most popular. Bit of a problem with John because 18 and 20 are equally popular. Now, we deal with that in a number of ways. We could just say the mode is 18 and 20. A set of data with 2 modes is called bimodal. It's like biplane with 2 sets of wings, so bimodal, 2 modes. Or we could just say there's no mode. No mode. There's no one value that's any more popular. In fact, the mode is probably the least useful of the averages. So we can now say that typically John takes 21.6 seconds to run 100 meters, whereas Bill takes 20.7 seconds. So Bill is faster. Or we could look at the median and say typically John takes 20 seconds and Bill takes 21 seconds. So John is faster. So this is the problem that averages often present us with. It depends what average you choose to use, doesn't it? So if I was John, I'm going to use the median because that makes me look better. And if I was Bill, I'm going to use the mean because that makes me look better. And this is one of the issues with data. We can often make data say what we want it to say. And you have to be really careful when reading in the newspaper about this survey or this evidence, because it's very easy to interpret one set of data in 2 different ways. So that's the average. We've looked at calculating a typical value for both John and Bill, but I said there was a second thing that we can do, and we'll move on to that now. So the other thing we can measure is the range. Now the range is a measure of how spread out the data is. And a good word we often use with range is consistency. If data is very spread out, we say that that is inconsistent, whereas if it isn't very spread out, we say it is consistent. And the range is easy to calculate. We just take the biggest value and we subtract the smallest value. So for John, his biggest value, if I look at my median list, was 35. And his smallest value was 18. So his range was 17. And for Bill, his biggest value was 23 and his smallest value was 18. So his range was 5. And of course that's seconds. I haven't been putting my units in, which is very bad. I should have done that up here as well. Sorry, you can't see my, there we are, right. So we can now talk about how spread out the data is or how consistent they are. This is John, remember, on the left, and this is Bill on the right. Very important that you don't confuse this with an average. This isn't another average, it's not a typical value. It's a way of measuring how spread out a set of data is. And the range on its own is useless. It's useless saying his range is 17 seconds. It's only useful when we have 2 sets of data. So John has a range of 17, Bill has a range of 5, so I can say Bill is more consistent. John is inconsistent. His times are more spread out. So who's the better runner? Well, the mean suggests that Bill is the better runner. The median suggests that John is the better runner, but Bill is more consistent. So I'm going to go with Bill because the averages were inconclusive, but the range suggests that he is more consistent. So you have a 4-page PDF attached to this homework, but don't be afraid, I only want you to do 1 page of questions. So if you are someone who really can't remember the averages, then I'd like you to have a go at questions 1 to 7. And at the top of the page there's a reminder about how you calculate the averages and the range. If you're someone who is pretty confident with this, then I'd like you to have a go at questions 8 to 11. They're on the second page, and in particular question 11 is one that makes you think. And then the third and fourth pages in the PDF are the answers. So once you've done your work, you can check your answers, and please feel free to get in touch with me if you have any problems with that. So this is work for Monday, and on Friday I'm not going to post a new video, but I will post some problem solving tasks based around averages. I do hope you are well.